It's it's interesting about sort of planning and architecting the knowledge graph, which is, Alex, you've spent a better part of the past, I don't know, 6 years, 7 years doing.
8.
8, yeah. But I mean, but it's like one of the things is you almost think like each node is like an intersection. You can't have too many roads coming in of into a single intersection. Otherwise, it's a mess. You typically don't want 4. Occasionally, you have a 5. Every city has their like 5 points, right? Every occasionally, it's always kind of a pain. You get in there and it's like the light situation and all the crosswalks.
Yeah, and you try to avoid those intersections because they're such a headache.
Right. It's like, oh my God, it's the only way we can get to the zoo is we got to go through that 5 points thing in Lincoln Park. You actually know where they are. They're, that times just like cool places, but it's like it's not efficient, right?
Yeah, because you got emotional scars from it.
Right. I don't know. But so Alex, like, with that analogy in mind, I mean, when you kind of think of heuristics, you're like, okay, when do your spider senses start tingling? When you get too many prerequisites, is like you don't. It's like 2 to 3. 1 is great. 1 to 2 is great. 3 is okay. 4. Like, what point do you go? We just can't feed too much into 1. That's causing a type of a cognitive congestion.
Yeah.
Right? Like, what would you say?
Yeah, so I think in terms of direct prerequisites, I usually say like 3 or 4 is probably. I start getting feeling uncomfortable when it's anything more than that. But we have direct prerequisites, which are so in the knowledge graph. They're sort of like it's like one edge connecting the topic to its prerequisites. But we've also got this other thing called, as I mentioned before, key prerequisites. Like, and each knowledge point within the topic, each topic is broken up into 3 or 4 knowledge points, and each of those knowledge points has its own set of prerequisites, which are key prerequisites. Now, some of those key prerequisites might also be direct prerequisites, as in they would have studied it not that long ago, but some of them can be actually sort of quite sort of like detached from it. Like sort of like it might be sort of like 3 or 4 jumps in the knowledge graph, maybe even more. So you're bringing in knowledge that students studied like at some point in the past, and when those start stacking up. I think it's when my spider senses really start tingling. Like every single knowledge point needs like 3 or 4 key prerequisites. It's like, this is feeling like cognitive overload problem.
Right, because the direct prerequisites are kind of like for the topic as a whole, but the key prerequisites are for each particular knowledge point, and that's really the pressure point. As the student moves through, right? It's one knowledge point at a time. So you want to measure how much cognitive pressure on each knowledge point. What's interesting is that you said 3 to 4 prerequisites. I mean, when you look at working memory literature, somebody can hold about 4 chunks of information in working memory. That's about your capacity. So it's just kind of interesting.
Coincidental, correlative, or what determinative. It's interesting. So I mean, one thing we is this knowledge points are something more we talk about internally. I don't know how much we talk about this publicly, but every topic is divided into typically 3 to 4 knowledge points. In extreme cases, you have 2 or 5, but typically it's 3 is the ideal, and sometimes 4. And what that means is the student progresses through a topic in does the most basic vanilla version of that topic. Just get some wins, just get a basic concept down, and then the next knowledge, the second knowledge point might add a little bit of a twist. Okay, now we're doing negative numbers or odd exponents or whatever, something that, and like, okay, they do it. And then the next one is like another twist. Okay, now we're using fractions or radicals or exponentials or something about it that makes it even maybe a little more nuanced or tricky. And the fourth one might even pull them all together. So it's sort of like this. If you were teaching a student to do something like I'm solving linear equations or I'm taking a derivative, you start with the most basic and you progress. And once they do not go to knowledge point 2 until they can at least do 2 problems correct in a span of 5 in the current knowledge point. So then okay, you got a couple. Okay, good. All right, that's good. You did that. You took a derivative. Okay, 3x squared. Okay, that's 6x is derivative of that. Okay, now let's try it. What if it's 2x to the negative 5th? And then I go, negative. Well, negative 5 times 10, and then whatever. And then and then so you kind of build confidence, and you do that. So anyway, so for our viewers, listeners, whatever, it's knowledge points is just a way of separating and creating a step, a sort of a ladder within a single topic. And individual knowledge points can have specific key prerequisites. So if you were like, say, okay, the third topic introduces, radicals somehow into this situation, it's like some prerequisite might be sort of like algebraic operations with radicals or something, right? So something like that.
Yeah.
But it's interesting. I mean, there's probably a lot we can talk about, maybe postpone it for some later shows about, your methodology and what you've learned and all the heuristics you've developed for like, how do I create a knowledge graph that's effective?
Yeah, and this is not just based on your gut. I mean, part of it is based on your experience as an educator, but a part of it is also just looking at cold hard numbers, analytics on this thing. It's like you're like the city planner with all the traffic routes and everything. But the nice thing is if there's a 5-way intersection that's just not working out too well, you can just like pick up the roads, like rearrange it.
Yeah, that's a great analogy. You can imagine you're like the head, city planner, right? And you have some young guns come in and they're planning. You got some new part of the city that's going to put some roads, and you initially come in and you're like, that's not going to work. They're like, what do you mean? You're like, okay, look, you got that's an exit from a highway, and then we got a subdivision, and then they're going to be like, and this. So you would say, look, so you would instinctually know, having spent years doing this, where there are likely going to be problems. But then at the end of the day, you do your best, and then we start getting data in, and it's like students are struggling with this topic. We have a pass rate that's not at our benchmark of 94, 95%. It's 75% or something. Like, what's going on there? And then you go, and Justin had built a bunch of analytics, a bunch of tools that you can use to sort of inspect and go, okay, where are students struggling? You're struggling at knowledge point 3. They're fine up to knowledge point 2 and knowledge point 3. And so then it's like, what's the problem? Like, what is the problem? And typically it's one of two things. We're missing a knowledge point. Sometimes it's like further elaborating on something, including a graph or more detailed description or something. But a lot of times it's inserting another knowledge graph, because it's like having steps, except you're missing a step and people have to step 2 steps up and it's just too much. Or sometimes it's splitting it into 2 topics, right? I mean, I don't know, it'd be worth just talking about that for a minute, Alex. And how do you?
Yeah, it's funny actually. I remember the first time that I said this, Jason. I think I really need. I think it was you at the time. It wasn't Justin. I said to. I think I really need a tool for splitting topics like into 2. Like it's like this topic is overloaded. I want to be able to split it there. I remember you were like super busy at the time. I was like, well, I really hope that this is worth it, because this is going to take me like all weekend to do. And I must have used the split tool, I reckon, like 500 times. It's hard for me to say, because that is the solution to so many ills. Just break this damn thing into 2 topics. They don't have to do Euler's method, 1 step, multiple steps on the same day in the same lesson. Let them do 1 iteration first, split the topic. Multiple iterations can be once they've demonstrated mastery of that, and you sort of have sat in their brain for a day or 2, then they're ready. So that is that's been incredible. That is like a savior, because like I said, we spend a lot of time looking at data, like student performance data, and we can see exactly where students are struggling. And like you say, it's often. You just kind of have to use your experience as an educator to understand, well, what's the most likely problem here? They're getting confused because the diagram doesn't work. But often it's just trying to do a little bit too much in an individual topic. Just split it. Everyone's happy usually.
If you break it down small enough, it's like you can explain anything. If you break it small enough, like into small enough step, it's usually trying to do too much. It's usually they're trying to take too big of a jump, and then people just fall off. It's like, rather than stairs, I used to think of it as like rocks placed across like a creek or something. And it's like, okay, well, if they're 3 inches apart, then grandma can, wherever you walk, grandma can do it. If it's like 8 inches, it's like, well, my mom and dad can do it. Well, okay, now it's 1.5 feet. It's like, well, I can do it and stuff. But now it's getting to the point where it's like, well, my son can do it. And it's just like 3 feet, and you're like, and it's like, that's what happens. It's like, well, only super gifted, brilliant people can do it. It's like, because the pedagogy is so bad and the jumps are so big, you need someone who can do a standing broad jump of 9 feet to make it, right? Otherwise they're landing in the water. And it's like, okay, rather than writing textbooks that have these 6 and 8 and 10 feet jumps every 2 or 3 pages, and it takes them with incredible athletic ability, or incredible mathematical aptitude to make those jumps. Otherwise, they're just like, man, I don't know. I'm like, I fall into the river and I'm floating down the creek and like, oh, what, this sucks. So, for so going back to that split tool. So it's been a long time, so I'm trying to remember, but I remember initially, because this is back, we didn't have many. It was mostly just the school program, and maybe
it could be.
And we would like split live topics.
Yeah,
we would lock a topic. Well, first we didn't even lock topics, and I'd be like, Alex, make sure you don't split it after, because we did at that point we had one beta tester, one person who used to be in the school program, and she had moved, her family moved away, and the dad is like, what am I going to do, Jason? They don't teach calculus in 8th grade. I need to math cats. So we had them using the system, and she was like on the East Coast, and I was like, okay, come 8:30, 9 a.m. Eastern time, because sometimes she'd do it in the morning before she would go to school or something. And I was like, you can't be splitting topics. You got to have it done and split by that time, because you're in the UK, so you only had so many hours. And our students in California are doing math up until as late as 11, sometimes midnight Pacific time. And so you had this relatively narrow window in which case you had to do it. And you were kind of stressed by that, right? You're like, right? I remember that being a stressful thing for you.
I mean, obviously, there's times when things are extremely raw and things can break. It's a stressful experience to know that you've done something which has caused some kind of break, and that happened in I mean, it's much rarer now, but but yeah, obviously in those very, very early days, yeah, it is kind of a stressful thing. Like, oh, if I do this, is anything?
Yeah, we were just kind of flying by the seat of our pants back then with the like, oh, it doesn't look like any students are working on it. Okay, you can do it, but have it done quickly. So it's like that only. I mean, that works when you have like just a handful of students, right? But just eventually, you just get into a state where like there's never a break. It's like you're the city planner, right? And now there's never a break in traffic. There's traffic at all hours. There's like and
we're like every country now in the world now, so
yeah, right, exactly. And so it's like we really there's a lot of stuff that has to happen behind the scenes now, where it's like, okay, we lock a topic. Well, you clone a topic, get it all prepped for the switch, and then we're like, okay, it's ready to switch. We lock it really quickly, do a little nice switch onto the new topic, swap everything out, and then unlock it.
Well, it went through a progression. It went through progression. Initially, there was no locking. Like a student could literally click on it, and you were like, hurry, get it done. We were like, make sure you have it done by so. And then Justin and I worked on a thing where you could lock it. Like if a student was using, or they tried to submit an answer and was locked, it'd be like, this is under construction, sorry. And so the student would be like, so worst case, I mean, we tried to avoid that too, but you would lock it, and then you would do the surgery you needed to do, whether it was splitting or adding additional knowledge points or moving questions around or whatever, and then unlock it. And then we'd have the students lesson or whatever would update it as necessary. But then we're like, that was fairly limiting and stressful. And then we're like, okay, I remember Justin and I sitting around thinking like, okay, how are we going to do this? And we're like, all right, I think what we need to do is we got to clone this sucker, clone everything, the question, the knowledge points, all the related records to this topic, so that you can do whatever the hell you want. And then Justin built a whole suite of tools, command line tools that you use, that you would like clone it, and then you do all the stuff you want to do, and the team could work on it and do all the stuff they wanted, and then you would build some tools where would then, I don't know what's it called, what's that? You would get a knife switch, would just insert it in, it would replace it, right?
Yep. That's right. Yeah, I'd do everything really fast. Right, because the issue that we encountered with just locking is like, okay, well, in theory, like, okay, in theory it's fine as long as you get it back up like relatively quickly in the same day or something. But once you get enough students, you get to a point where it's like, well, we have 1, 2, 3, 5, 10 students who need that topic to make any progress in their course. Like they're bottlenecked. And they're bottlenecked.
We're going to get emails. We're going to get emails from
exactly
teachers, from parents. Right. Sandy's going to be like, what is going on? I'm getting all these emails, you know.
Yeah, right. So now we're at a stage where every topic is needed by every student. All like at any moment in time, there's enough students needing every single access to any single topic that we can't take anything offline for even a couple hours. Right. So that's how the knife switch tool came into being. Where it's just
I think that was some of the very first command line tools that you built for Alex, right? And now this like hundreds of command line tools or something. Each one is like a lot of, it's like a Unix.
There's
program that has all these options. Like Alex has this huge toolbox.
Yeah. Well, I think it started out actually the first command line tools that I built were validations to make sure just that things are all set correctly.
Whatever he did didn't break anything.
Yeah, stuff like that. And then knife switch came after that. But yeah, we've got hundreds of command line tools, and actually we've even got like maybe like 100 validations that run periodically every so often to make sure the system is in a stable state. And each one of those is a command line tool. If there are any issues, it'll spit out the description of the issue and stuff. And so I've got a validator that goes through, runs those, collects the output, pastes them to Slack so it can notify us if there's any issues.
I mean, that stuff we don't have too many problems these days with knowledge graph, any of these things, right? I mean, this stuff is pretty...
No, but we used to. Alex, do you remember how stressful it was to tweak the prerequisites and worry about introducing a cycle or just some kind of invalid graph connectivity that then the model just falls over and dies?
That was the worst. Yeah, cycles were the worst. And it did happen a few times. I make some kind of change, and then all of a sudden we start getting complaints. There's no validation. There's no like validation tool that's kind of spitting stuff out. It's just stuff isn't working. It's like, we think there's a cycle in the graph. What's going to happen? You know, what's going on? So I had to kind of like retrace my steps. Oh, okay. I think it might be there. So go back and tweak the prerequisites. Is all fine. But that was extremely stressful because I remember exactly what you did to.
It's like playing Russian roulette knowledge graph edition. And you just do it enough times and like something breaks and like it's the whole thing. And so now we got every single graph change that you put in, it gets validated to make sure that it can go that there's no mistakes being introduced into the knowledge graph unintentionally. And I've even got like a self-healing, self-repair in the model so that if there are any issues, it does its best to try to keep on functioning despite.
Yeah, right. Well, first of all, one thing I wanted to say is, for people who don't know what a cycle is, it's like A is a prerequisite of B, B is a prerequisite of C, C is a prerequisite of D, and then D is a prerequisite of A again. Like it is. So you can have, that's a cycle in a graph. I would call an acyclic directed graph. It's when people think of graph, it's not like a graph like I'm graphing a line. It's a thing of nodes and edges, so things all connected to get the knowledge graph.
Yeah, it's a connect the dots sort of thing, right? Exactly. And so it's like the stepping stones, right? It's like the stepping stones somehow go in a circle, and you're like, wait, I'm supposed to be crossing this river. Why are the stones going in a circle? Obviously, it's not what we intend to do. But when you got so many, like when you got thousands of topics and tens of thousands of prerequisite edges, it's easy to sometimes just type one number in wrong, and now you've got a prerequisite.
Easy. I mean, we're human.
Pointing to the wrong topic.
We make mistakes, right? Alex types in.
Exactly.
Oh, it's 1, 2, 3. It's topic ID 1375, and he accidentally types 137, and they didn't get the 5.
So gotta catch that. You gotta have automated catches of those things because it's just there's some amount of human error that's just you can't avoid it in the aggregate. But and the cycle, that's just one example of an invalid graph connectivity. There's actually like maybe 4 or 5 different types of these things. There's gaps between courses. There's a number of things.
Topics there's topics where you could have like, here's a course of 200 topics, and there's a topic that's a prerequisite that sits in between 2 topics that's not in the course.
Yeah.
Right. It's
exactly
like that.
Yeah. It's like there's an intermediate stepping stone that is not included in the course.
Not in Algebra 1. It's in geometry. Like, wait, what the, and that's stuff is easy to do sometimes, I mean, or like back in the day before we had all this tooling. But I mean, I remember the reason we built the tool is because Alex, you'd be like, well, it'd be really useful if I had this and really useful to have that. And when you have to build a whole like UI for it, I mean, it's just 10 times the work of just creating a command line tool, right? Because there's all these like, well, in the base case, you just write a button here and this and that, and like, well, what if they do this and what if they do that, and you got to check this and you got to show that, and it's like it just blows up and it becomes a whole thing. And meanwhile, I'm trying to build all this stuff for our actual customers and students and parents and school, whatever. And you're like, Jason, I'd really great if I had tools to this stuff, and I'm just like, dude, I mean, how badly do you need this? And so I was like, all right, Justin, could you just write a command line tool? Or just because Alex is the only person who's going to use it, so it doesn't have to be this. And he's
don't
going to
need
be an
an
expert.
interface.
Yeah.
Only customers get clickable buttons and scroll. Like Alex, like you're going to have to pipe the text into an output file and just read it there.
Yeah.
But it's probably works for you though, right? Having a bunch of these tools, because if the thing is if you have command line tools and you're fast with it, it's actually. I mean, all the Unix heads will tell you it's like they prefer it, right? It's so much faster if you know your fingers are, even muscle memory in your fingers to do all these command line tools, as opposed to clicking crap around, right? I mean, how they work for you?
Yeah, I mean, when you first suggested the idea of having all this stuff as command line tools, straight away I jumped on the idea. I was like, yes, that's great. I mean, in a past sort of life, if you like, I kind of like did a bit of like Linux system administration and stuff like that. Like setting up FTP servers and HTTP servers and things like that. I kind of got when I was doing my PhD, I kind of got a little bit sort of like nerdy around that kind of thing. So I was super into it. So it's super fast. And there are some things that you kind of like need that sort of it's better for information to be presented in the UI, but for the vast majority of things that you're doing, like setting prerequisites and that kind of stuff, checking connectivity, updating courses. I mean, it's just way faster to do it using the command line. So
you were skeptical of some things, and I would say, "Can I replace this and take this away?" And you're like, "Whoa!" You're like,
that's different.
You're like really nervous about me taking away some stuff because like I want to deprecate this because this is just old. It uses a bunch of old stuff. We got to get rid of this, and we'll give you a tool. And you're just like, I don't know.
Right? Yeah, I maybe there were some things that I was a bit like, what's he doing? Cause I wake up one day, it's like the thing I need is just gone.
It's happened a few times where I've changed some stuff, and you're like, what happened to my thing? I mean, this is, you had a reason to be nervous whenever I was talking about, deleting stuff, but it was always funny. I'd be like, Justin, could we just build like a, tools? And of course it's just way faster to build them, to maintain them, give you all the, because a lot of times these tools have lots of specialized parameters, options, I guess they call them, right? A bunch of options. And that stuff is harder to implement well in a UI without requiring just a lot of UI work. It's often not as, it sounds, it's just always more complicated than that.
Yeah. And as the sole UI developer in the company, I would much rather you're working on like the UI stuff for the customers than for me. It's like, yeah, I'm happy with command line tools. I don't to be hassling you with like, oh, this there's a bug in the UI is preventing me from doing this, which probably takes like sort of 2 hours due to, I mean, well, it depends, but I think it's worked out.
Developers, you need to allocate their time as efficiently as possible.
Because there have been people on Twitter that say, well, I've talked about the command line tools. Why do you have a command line tool? Wouldn't it just be better to do a UI? It's like, no, it wouldn't. It really wouldn't. This is just so much faster, and it helps the product move forward so much quicker than it would otherwise. So yeah, I'm happy with my command line tools, and I've got no need to change anything. The only thing I probably would say, yeah, an analytics dashboard would be kind of helpful, but we have analytics tools, so it's not like I'm completely in the dark or anything like that.
Yeah, no, there's a lot to be desired in terms of, collecting analytics and making, I mean, Justin has some reports that he runs, more with user behavior and churn and this and that, but there's a lot of the stuff that we should just build out in some tool. Probably start with tools and then build some dashboards.
Yep.
But yeah, I mean having the tools was hugely effective. Also, was great because you could complain to me and I'm like, go talk to Jeff. I don't want to. You're like, wrong.
Yeah, frees up a lot of your
department.
bandwidth.
Yeah,
wrong department. Yeah, it was, speaking of it, was sort of funny. Like when I think back in the earlier days, you know, initially, Justin's background was, he did machine learning, quantitative stuff purely. And a lot of it was sort of like, when he worked at that, analytics company, there were engineering teams, and so he would just work with models and data, and they would build out the infrastructure. And so he would do stuff in like Jupyter notebooks and stuff, and everything was Python, and that's how kind of we started. He would write everything in Python, and I would actually convert it. I'd rewrite it in JavaScript because we were a node on the back end, right? And eventually, I'm like, all right, this is bullshit. You gotta write this in JavaScript. And you're like, I was like, I'm like, just, and he was like, okay, all right, I'll start doing it. And so he started doing that. And then he would push the code, commit it, and he'd be like, all right, it's ready to deploy. And after a couple months of that, I'm like, all right, this is bullshit. I like, you know what? Here, you're gonna, because we had it running on a whole separate server, right? This isn't the main app server, a whole separate. We had our first sort of engine, whatever server. And I was like, all right, Justin, look, you're gonna deploy this code yourself, and you're like,
yeah. I came in with very, very little software engineering background. I mean, like I could basically, I was like a just mathy code stuff, research code,
quant
little
code.
notebooks, little scripts,
You're a quant.
like leet code type of problems. Yeah, I'd never
no
managed
UI
the
work,
server.
no
UI.
admin,
Yeah, no. But yes, there was definitely a spin up period. But it was one of those things where it's like, I guess back to what we were talking about at the beginning of the show, is like, okay, I had a strength in mathy coding, but like until then I had kind of just like leaned into that so much that I never developed the rest of my coding abilities, and that was a severe weakness. But the silver lining of these severe weaknesses is once you shore them up, then you become so much more capable on so many more fronts. And so yeah, I mean, it wasn't fun realizing just how lacking I was on the software engineering side of things as opposed to the quant. But once I just like dug in and leveled it up, suddenly there's all the sorts of things that became available to me that I was able to start working on, and more kinds of work I was able to start doing, taking off your plate that I wouldn't have anticipated. And yeah, it turned out really well.
If you recall, how this all happened was when I first asked if you wanted to work with me on this project, and you were like, hell yeah, right?
Yeah.
And we would pair code at my desk. Justin would sit here, I would sit here, and we would pair code for hours. Justin, you were working full time at the time. I think you were still working at that private school, and you would come home. You would be here at like 3:30, and we'd work together until dinner time. We'd eat dinner, and then you and I would oftentimes work through the evening, unless you didn't have something scheduled with Sanjana or something. But we would pair code for hours and hours and hours. And I would kind of just talk about the philosophy of software development. I'd write simple, short functions, write them, shorten them, and then shorten them more. Simple classes. Really, really pay attention to how you name things, because that if you can't name something, there's probably you're trying to do too much, or your thinking isn't clear enough. It really helps if you want self-describing code. If you have to write a lot of comments, that's usually a danger sign, and you want to, so I would just go through all this sort of like just the heuristics of software development, not just write coding, but how do you write larger systems, like short files, sort function, cohesive, make things object oriented, whatever. And it's all about the art of managing complexity. And of course you were picking that up quickly, because you were initially just writing like code like most quants do. You would X and Y and whatever.
Yeah, oh my God. I look back at old code like that and just cringe internally. It's so bad. But yeah, I mean,
it's just what you do. Because your code was never more. I mean, as all these grad students, undergrads and grad students in math and physics and who are writing stuff for classes, their stuff is never more than a few hundred lines long, in which case complexity is not the problem. Managing complexity is not the problem.
Right.
Having somebody else have to look at your code when a bug happens at midnight and they're like, what is not your problem. So you don't even, those aren't problems that we're solving. The problem is like, hey, how do I get this algorithm to do these things I need to do, because that's the assignment or that's my research and I got to get this stuff done. But when but when you're writing software and you have these very complex systems that have millions of lines of code and all this stuff, you have to think about everything completely differently. So anyway, we did that for, I don't know how long, a couple months or something like that. And then, but as over time, you'd be like, well, I can just kind of work on this part, and you'd go sit over there in the living room, and you'd kind of work on the quant code, and you at that time you're doing it in Python mostly still, and I'd be here working, and you're like, all right, well, I got it, and then I'd convert it, and then eventually it was like, right, not Node, and then over time, you would write bigger and bigger, more and more code that was just solid. And that was just me just kind of like, okay, merge, think. And I was like, okay. And then because you would need code, you're like, can you deploy this code? And I'm like, we're at dinner. I can't deploy it now. So we got to put this fix in. There's kids that have it. I'm like, all right, like, this is bullshit. Like, you need to be able to deploy stuff. And I remember you were just like I said earlier, you were just like, what? And I'm like, look, just, SSH in the server, and so I'd give you all this stuff, and then you started doing it. But what's really funny, because the learning curve happens, is then you deploy something and it blows up.
Yeah.
All of a sudden, all these errors start happening down, emails are coming, and then that was a whole nother learning curve of how to write bulletproof code. Because there's only so many times of stuff blowing up that just is so anxiety inducing. It's so stressful. It's such a horrible experience. All these emails, nobody's got tasks, this thing's wrong, and so then you start going through the process of learning how to write code that's bulletproof, that won't fail over, that won't fall down, that's logging everything. Because then, like, what happened? I don't know what happened. If we're not logging stuff, or how to alert us. I don't know. So I talked a little bit about that, because I thought it was really an interesting. I mean, the biggest growth happens when somebody says, "Here, you take care of it," and you're like, "Oh shit,"
Yeah, yeah. That was pretty much right. So it's like it kind of felt like you just gave me this code baby, this robot to take care of, and you're like,
"You're your code baby.
Don't kill it." Like, I trust you. But yeah, it was very much. I mean, it's just stuff that you can't. I mean, okay, I did not study computer science in college, so I didn't really have any sort of background in this. So I was just learning the hard way, right? School of hard knocks. Like, all right, crap, code blew up. Well, I guess they don't really teach that a whole lot in computer science programs either. Is that I guess everybody learns this.
Learns this right? As the software developer, as an engineer working, building production code is where you learn it. Yeah.
I remember. It's just various things. It's like at first there's just unknown unknowns that you just don't like. You don't realize that, like, there's things like cascading failures, that like one thing fails, it causes another thing to fail. You don't realize the magnitude of a screw up that can happen just from one small thing. And so you think, like, well, I'll just make things not break internally, right? Well, that seems like a good idea, and that's the first step. But then there's another step, like, okay, well, what if something does break? What happens then? We need to limit the breaking in its scope, not to have it like cascade out to other things, because just something's gonna break at some point, even if you're as careful as possible. Like, that's just, you're gonna deploy a typo, or your tests are not gonna catch some case, or somebody is gonna run into some scenario that you just never thought would have ever happened, or somebody's data is going to be corrupted for whatever reason, and then you got to make sure that doesn't screw up with other people. So it's just lots of, I guess, more and more advanced sort of error handling and writing this kind of robust code.
Well, that was what you had, what is known as autonomic code, which code that can self-heal, right? So that you started writing some autonomic code in the model, so that if something got screwed up, so if Alex had made a change and there was a problem that the validation didn't check, that it wouldn't blow up for everybody, because when that happened, that would just like ruin your night, right? And because Alex is
yeah,
doing this in the middle of the
good.
night, and all of a sudden, bam, 4 a.m, and you're just like, what is happening? And all these emails from people, and nobody has tasks, and you're just like, okay.
Yeah, right. So it's like don't let don't let the system be adjusted by the command line tools unless you validate beforehand that nothing's going to screw up. And not just like theoretical validations, but like actually have the model go and build its knowledge graph and everything to the point where like you are 100% confident, like it's guaranteed to be able to select tasks. Run that same exact code every time you try to make a change to the knowledge graph. Because that's the standard that the change has to meet in order to avoid these disasters.
Well, and that was when we would joke. We always, I started saying, like, if you haven't tested it, it's broken. Just assume it's broken. I mean, it is. It's like so often, that's the case. You might as well just assume it's broken. But the other thing that was really interesting around this time is when we initially had the first real version of the knowledge graph working. This is back 2021 or something. I don't know. And you would calculate. You would have to update a student's tasks based on their updated knowledge profile, and they would go through all the answers that they had given. It would go through an entire answer stream and project that onto the knowledge graph and percolate all the changes up and down to find out what their knowledge state is, and then figure out what are the optimal set of tasks for due and select the tasks and stuff. And I remember rerunning that, and I'm like, well, how long does it take to run it? And it was like a student who wasn't super advanced but had done stuff. You're like, about like a minute and a half. I was like, that's never going to work. You're like, what do you mean?
Yeah.
I'm like a second? Or you're like, what? I'm like,
yeah, this was my first intro to real-time systems. Because previously I'd been like coding up like research kind of stuff, like computational neuroscience or whatever. It's just like you just run a simulation. Like, what do you mean? It runs in a minute. That's fast. Like I can just, no, that's not fast. That's not fast when you have, when this thing needs to be run over and over again. And especially like when it's going to have to scale with the number of tasks that are completed on the system. Like, yeah, so that was a lot. That was a lot of good learning and just how to leverage caching to speed things up. There's all these sort of tricks.
Yeah, well, so one thing I kept that I would say when I were telling you in the early days, like, you can't make code run faster. You could just make the computer do less. And how do you make it do less? You don't make it do the same thing over and over again. And how do you keep from doing the same thing over again? It's like you identify stuff that it can reuse from what's done before, hence caching. So what information do we have? So what can we calculate, pre-calculate, and save in a certain state that we can just pull from? And so there was a lot of work done from that got it down, 100x faster.
Yeah. It was one of those things where it's like, coming from a mathy quant like background, like caching, like you don't really think of caching like just as internal to an algorithm to make the algorithm run fast enough, but there's like this that's just on a small scale. There's large scale caching of all these objects that you need that are feeding into various things. And as like previously I for whatever reason I don't realize like how broad in scope you can push this idea of caching, which it's something that we realize over and over in our work here, right? Which is like if there's a solution that solves one problem, like you can probably push it a lot further than you're thinking. You can lean into it. For instance, just the idea of like spaced review in learning, like just not just tech, but like everywhere, spaced review. If you like, okay, good, let's prevent students from forgetting the material, but also if you really lean into that, you can actually make it super efficient so that they barely have to review stuff. They're getting a lot of review credit implicitly. There's all these like little things that you can just push way further than you would expect.
It was because when you first started working with me, I think we've talked before, you were like 22 ish. This is 2019. So
I was 22.
Right.
Turning 23 in August. But yeah, I was 22.
Right. So and so you were young, you had never written production. You had a lot of experience. You worked all through your undergrad years, just 3 years in an analytics company. So you were really advanced for your age in machine learning and sort of commercial grade analytical type of building analytical solutions, but not on the engineering, production, real time, all that kind of stuff. That was the where, and then just proper software development method, techniques. So, but of course, you leveled up quickly. One, because I could sort of give you lots of shortcuts. Hey, just here's how you want to think about it. And so you're like, all right, fine. And you were highly coachable, extremely coachable. You would just I tell you one time, and you're like, okay. And then so you leveled up. But the second was like, all right, you take it. Like it's yours now, because I can't. I have too much. And so then and then of course, and it was I would sort of laugh. I mean, it's like when things did blow up, I'd be like, oh, that sucks. But I'm like, well, this is a teaching.
Yeah. yeah, exactly.
I could tell you were frazzled. I could see you're like, oh.
Yeah, I remember that. I think the first time I accidentally blew up the task processor, I was like, I nearly puked in the toilet. Like I was just at my place, so you didn't see all this happening. But I was like, for a good minute, I was like just feeling like I was about to pass out or something. But then it was very stressful. But that was, I mean, like we always talk about, it's like that emotional scar tissue just guides you in the future. Like, okay, we're not going to do that again. We're going to. Every time I'm writing code now, I'm thinking like, how can I not be in that situation? And then I haven't been in the situation since.
And it's not like I had to be upset about it. I'm just like, oh, that sucks. I'm like, I just sit there and go, I'd be like, all right, well, how's it going? You're like, oh, I'm working on a thing. And I just was like, all right, well, and like he's learning. I mean, because I've done it too. I've blown stuff up my share of times, and it sucks. It sucks. But it definitely teaches you to have respect for the process and get you to do all the right things, because you're just like, I don't want to have that experience again. It's just terrible. It's terrible. Things blow up. People are upset. Everybody's confused. The customer support emails are coming in a flood. Nobody can log in or do. And of course now we're at a scale where it's like it would be just like bam. I mean, that's why it's good to start small and then like grow organically, because then all these skills and tools and processes and everything can evolve over time, so that when you do have a larger scale, it's not like, oh no, what do we do now? It's like it's just 1% bigger than it was. And, there are, and so, but then what does happen, and this happened with the database server and stuff, things will just suddenly hit a point, and then it just goes like this, like with that, the pressure on the database. That was a big problem like 2 or 3 months ago or whatever, right?
Yeah, right. It's I think it kind of comes down to, again, like the cascading failure thing, where it's like you get in a regime where one thing goes wrong and your system is kind of in this weird state where it's being pushed up against some limit, and then suddenly like these failures can spread all over. Right. I remember. I think it was last summer actually, right, when the database hit capacity, but it was kind of getting pinned up to this like 99% utilization, and then it was like people's tasks started to become slow, or like the dashboard loading page, because like I guess there was a particular query that was pulling in all the data for the leaderboard on everyone's page that was kind of running slow. Why was it running slow? It was running slow because the database was pinned. And so this query wasn't running as fast as usual. And so because the query wasn't running as fast as usual, that means everybody is just kind of hanging on this dashboard page. What do people do when they're just hanging on the page? Well, they go refresh the page. Now that's running more and more queries. Now we have it's just this huge explosion of just bad. So right, so like learning to just keep everything in a stable state, and
it's a margin, because it went, it was like a 20%, 10, 15%, 20, and then it started getting up, and then it went to like 80%, and then within a week it was at 99.8%. Like it just was like, you're like, okay, is this a little, maybe we look at some problematic queries, or are we missing an index or two, or on some tables? I mean, what's going on? And it was just the growth. You just hit these inflection points with growth, so you have to be careful about keeping your margins. You need to be operating with some headroom, otherwise, or have infrastructure that can auto expand in the way that you want it to, which is sometimes harder than you than you think, and more expensive to get all that stuff in place unless you're some massive company that has a lot of money and you can just do all this. So Alex, are there any more topics that you want to talk about? I mean, we've been going for over 2.5 hours, so we don't have to keep going.
Well, there's a couple of things I thought maybe we could talk about. One thing I wanted to discuss was how we deal with like some of the smaller problems that occur that we hear about at Math Academy from students. So I was listening to like a video of Jeff Bezos a couple of weeks ago, I think it was, and he was talking about like some of the processes that take place at Amazon. And of course, you've got the big exciting projects, the new data centers, all the cool UI stuff they're doing, new products, all this kind of thing. But he was talking about, okay, so those are great, but what we have at Amazon is a papercuts team. So when a customer has an annoying, unpleasant, but not big scale, unpleasant experience, that's a problem for us. We need to kind of root those out and fix those kinds of problems. And I thought to myself, that's a really interesting idea, the idea of having like a papercuts team, because we hear about things like that all the time. I mentioned to Justin that one of our customers, he's got a 9-year-old student on the system, and it's gotten to the point where this 9-year-old's math abilities kind of outpace his reading ability. So he's actually reading all this stuff, which is really aimed for like high school reading ability students, and he's 9 years old, and he's running into problems where not only is some of the texts maybe just too much for him at that age group, but also certain concepts he just has no idea about. Like, for example, he was doing we've got a topic in Algebra 1 called mixture problems, and he's like, one of the issues, he doesn't really know what a mixture is. He hasn't had the science background to really appreciate what is a mixture. We say it's a mixture of water and salt. Well, what does that mean? 20% salt? What? So it's like I never thought about that. I never thought that would be a problem. So that's a paper cut. The kid's coming up against this topic called mixture problems. No idea what a mixture is. Too much text. It's like, okay, that's a paper cut. They managed to get through the lesson, but obviously. I'm sure doesn't mind me mentioning his name, Raheem, whose kid it is. He sat next to him and got them through the lesson. But it's like I need someone in the team on the content team who can deal with paper cuts. Whenever I hear about paper cut, I can say, right, this customer has had this problem. Here's a clone of the topic. Do whatever you want, but fix that paper cut. Make sure that paper cut doesn't happen anymore. And when you've sort of like define what it is. I mean, we're fixing like problems with existing content all the time. When you define what it is, it's like, this is a paper cut and we need a team to deal with those paper cuts so that they go away. It kind of draws a box around saying, is this thing is now a problem which we've kind of shaped, and you can now give that to someone whose responsibility is to make sure that is being dealt with. So as we grow and get more and more reports from people about these kind of things, we need to have a proper process at dealing with them. I think we're great when it comes to new content, rolling out new courses and stuff like that. It's all very efficient. We don't have too many teething problems with new courses, which is great. And that's brilliant. That's like the big infrastructure projects at Amazon. But you cannot neglect those little issues, little annoyances.
We're taking years to refine this process.
Yes.
Right. And a lot of introspection and sort of like troubleshooting the inefficiencies to get it to be as efficient as it has over the years. I mean, obviously, in addition to tooling and things, but just your processes, right?
Yes, and that's been our focus. Sort of growing the content base, growing the knowledge graph, and obviously taking care of the really big problems. If like 80% of students are failing on the lesson, that's not a paper cut. That's a huge problem. So that requires
even if something falls below 20%, if 20% fail, right? If it falls below the 80%, we're like, well, what's going on, right?
Exactly. So that is kind of paper cut territory. So it's like Andrew. There's one content developer on the team, Andrea, who's been with us for 7 years. She's always really impressed with her work, and it's just like, okay, now it's time, I think, to get Andrea involved in perhaps some of this. She knows the content inside out. She knows our standards inside out. She just sort of diligently done her role for a long time. It's like, okay, we need to solve this problem. I think this is the right person to do it. So hopefully she'll be the person kind of like heading that up. It's
So
just
do you
great.
have? Go on. Sorry.
Also, yeah, it's just great to kind of like name the problem, give it a catchy name that no one's going to think. Well, okay, it's not that catchy, but give it a name that that you can point to every time this kind of thing happens, so you can have a person that's responsible for that, and then you can make progress. Because I think that's one area where we need to improve. I think when people have those smaller problems.
Just getting on them and dealing with them quickly in a timely fashion.
Dealing with them quickly, come up with a solution quickly, shipping it quickly, doing the knife switch stuff quickly. That's something I'm really keen to get that process as good as our regular content development process is.
Well, it's sort of similar with what happened with Justin and I. Sometimes you just got to carve stuff out and hand it to someone. It's like, I just can't. Everything can't go through me, right? And like so much goes through you for reasons of just quality control and just because you have so much more knowledge about everything but it is a bottleneck. And so if there are things, it's like, okay, like you're identifying, there are things that I do not have to come through me that need to be done. Because if it just comes through you and you're like, well, I'm dealing with this course, I'm dealing with that course. And it's like, okay. And it's just like, it's the 17th thing on your list. And people are like, well, hey, we reported this a week ago or 3 weeks ago. Why isn't this dealt with? And you're just like, well, on top of everything else, Jason called me up yesterday and was like, hey, I got this idea, and so on top of everything else. So right. So having someone you can just say, look, just all these problems, I'm just going to send it to the, captain of the papercuts team. And she's just going to make it go away. She might ask me a question, but she will just make it go away. Right. I mean, that's the ideal, is that she has the skill, the knowledge, the conscientiousness and everything to just make these problems go away. So would you build a team for it, Ryan? Would you give her some people over time, have her deal with it herself at first and then add a couple people to it? Or what are your thoughts?
Just her to begin with. So she will do essentially what like people like Yuri and Josh do on the team. It's like they present me with like their proposed solution to whatever happens to be. We need a topic on X or topic Y needs to be improved. She does everything that needs to happen, and then she shows it to me, and hopefully I go, yep, that was great, and then we ship it to like what we call the production team that do the mass producing of the questions that we need, and then from there it's quite a streamlined process to get it into the actual system itself. So there probably will be some back and forth in the beginning, but once she's like really competent and knows exactly what she's doing, then that's the point at which we can maybe have two people doing that. So I don't imagine it being a very, very big team, like one or two people maximum, at least for the foreseeable future. But one thing I've realized over the years is that for this kind of stuff, for content development, because we've got so much and there's so many conventions and standards and things you have to bear in mind for creating content scaffold. There's just so much to bear in mind. You can't train 4 or 5 people at the same time. It's impossible. One is pretty much spending a lot of time with one person.
Does she have? Is one of her strengths that she has a broad enough knowledge so she can handle something on differential equations and problem statistics and different whatever abstract algebra? I mean, she can span these areas like you and Josh and Yuri. She's a mathematician. Is she a mathematician?
Yeah, she's a mathematician, and she's extremely competent. I mean, she's like I say. I mean, the reason I'm sort of considering her for this particular, well, we've had the conversation, is because whenever there's been issues with a topic, she'll often say like, "Oh, here's what I would do." She'll clone the question, tweak the explanation. Here's what I would do. I don't know if there's ever been an instant where I'm like, not sure. It's always been, yep, she's nailed it. So she's, so yeah. I think that I think she could do a really incredible job with that, and because she's been with for 7 years, she's seen the full breadth of the curriculum. She's seen the kind of differential equations we've got and the early years stuff, and yeah. So I think she'll do an amazing job, is what I'm hoping. I mean, there'll be some training involved, of course, but yeah, I've got no doubt.
That's great. Well, that sounds great. Yeah, we need one for technology too. We need like a paper
Yeah.
cut team.
On that point, so I actually announced, I thought I'd test the water with the whole paper cuts idea. So just on X a few hours ago, I was like, yeah, I'm thinking about setting up a paper cuts team for Math Academy. And, you know, we need to iron out all these little problems that people have. So, of course, people have responded. And I'm pleased to let you know that every single paper cut so far, what they consider to be paper cuts are all UI things. So...
Like me.
Not even a single.
We've all agreed there's a problem and it's you.
Yeah. So,
well, there's a lot of surface area on it, so it's not surprising. Yeah,
that's true. That's
A
true.
lot of surface area. Yeah, yeah. Well, when Colby, he'll probably put in some work over Christmas. So, you know, my son Colby, who's a senior now in college, he's studying math and computer science. So if he graduates in June, then he'll be full-time Math Academy, because that's what he said he wants to do. And so, and he's full stack. He's really good. He's built a ton of features that actually I got to roll out. He's like, Dad, have you still not rolled that stuff out? He's like, come on. But he may go back. He has one more. I think he has to do one more quarter. He has like 2 courses to complete his master's in computer science. And he's kind of like, Dad, it doesn't matter. Nobody cares. And I'm just like, well, it's, you know, 1 quarter. Like, might as well take your master's degree. But it's the worst case, we'll have him next year, but might have him sooner. So I mean, well, at least we'll have him the summer full time. But we'll have to look. I mean, we may expand the team a little bit. I'm just always a lot of times it's Justin and I found you expand the team, and
it's really hard.
I mean,
it's a lot harder than I thought it was going to be. I knew it was going to be hard, but it's just, there's so many challenges to be overcome. And the fact that, like, Colby, we already know he's got like serious development chops, and that he's really solid, and that like you and him work well together. I mean, it's so hard to find other people who are not only capable but also like work well together, and also have the background knowledge on Math Academy, right? That's another big thing, is like, you can't just like pull somebody off the street, pull a great coder off the street and have them like work on the Math Academy system. Well, there's a lot of like domain knowledge about how this system, not just like at a software level how the system works, but like at a like pedagogical level, and this being in the mind frame of a student or a parent. Like, how to you've talked about sometimes about all these decisions that go into the UI, right? It's like, well, it looks easy because like at the end result, like it's supposed to look simple to people. That's the hard part, is making it look easy.
Yeah,
like
making stuff look easy is the hard part, right? That's right.
Yeah,
that's a very good point. Yeah, for sure. So we'll see. I would love a papercuts team for the UI. Or just the app in just in general, because there are lots of things that are pushed off for the time being, because we have so many big things that we're trying to finish up and get out the door. So speaking of getting things out the door, let's finish with one more thing. We can cover this more in the future, but the next course to be released is our differential equations course, which is well underway. And why don't you let's just talk a little bit where we're at, what it is. I mean, however you want to describe it.
So so we're well underway with the differential equations course. I have kind of gone public and said that I'm hoping to release it before Christmas, because last year we managed to release, like, last year, probability and statistics on Christmas Eve, and that was what I wanted to do. It's like that'd be a great thing to be able to kind of maintain. I'm slightly regretting actually saying that now, although I'm still aiming for it. The thing I've realized is that a lot of these stuff so we've actually had quite a lot of differential equation stuff like in the background. So if you go through the Math Academy system and you complete all of our high level courses like linear algebra, methods of proof, multivariable calculus, discrete math, and probability and statistics, if you finish those, you start getting like what we call Easter egg topics, which are topics in the system, but they're kind of like not in any particular course which is available to the public. And the reason those topics exist is because is to help out with the high school program. Like years ago, you had all these kids finishing calculus at like 8th grade or whatever, and it's like, well, we need stuff for them to do. So we went in and we create a whole bunch of abstract algebra topics and differential equations, and and obviously eventually finished up all the multivariable calc and linear algebra. So eventually got them to piece into these actual proper courses. But I'm looking back at some of this original content, as there's so much we've learned about how content should be created that we didn't really know back then. So just to give you kind of one kind of example. So we got a probability and statistics course, and within that topic, I think the course has gone down really well, but there's 1 or 2 topics on moment generating functions where basically the way the questions have been designed, it's very easy for the student to kind of like infer what the correct answer is going to be, because it's like there's this particular pattern that makes it very, very easy to go, oh yeah, that's the correct answer. That's the correct. See 1 or 2, and then they can just, even if they don't know what the hell's going on, they can just kind of get through it. And even the most well-intentioned student who wants to know it, they might be tired, whatever, and they're just clicking and they're spotting the pattern and just kind of getting through. And a few people complained about this. Said, yeah, this is really silly, blah, blah, blah. So we've got a particular topic. We've got a big area of the differential equations course is going to be Laplace transforms. Now, Laplace transforms are basically the same as moment generating functions in a slightly different context. And it's like, okay, I've got to make sure we don't make that mistake again, So I've gone back. Now, Laplace transform is actually one of these Easter egg topics. So I've gone back and looked at it and gone, oh yeah, of course, this was created like 5-6 years ago. Of course, it's got the same problem as that moment generating function topic. So what I need, so basically, those topics almost have to be like completely rewritten. What we're going to do this time is, rather than just like multiple choice, whatever, it's almost use dynamic select questions to kind of like walk the student through the calculation. So they've really got to like think at each step. So there's quite a lot of work to do in terms of fixing prior, like not ills exactly, but to improve the content based on what we know is good practice right now. And of course, when we did the high school program stuff, there were certain topics that we just were I guess were missed, shifting theorems and things like that. So yeah, just going and backfilling a whole bunch of stuff. So there's a few other areas as well. Like one of the earlier topics is going to be like first order differential equations. Well, I've noticed a lot of resources actually kind of dive into like the method of integrating factors straight away, which you can understand why they do it, but actually they should go back and sort of do linearity first, really explore it, because there's some missing scaffold in there which could be exploited. But to cut a long story short, there's a lot of backtracking and putting things as they should be to create a kind of commercially viable course. So Christmas is definitely possible, but it's a lot of work.
So like one thing that I always, when I would say, hey, Alex, this is what I think we need out of this course is, it needs to be at the level of what you would see at Harvard or MIT or Stanford or whatever, right? Mm-hmm. So you don't want someone to say, well, that thing at Math Academy, I mean, it's not bad. I mean, it's just kind of cute, but I mean, that's not what we do at at Berkeley or Harvard or something, right? You want to be like, yeah, man, like it's legit, right? And so, one thing that I'd asked you to do when we created our very first university level courses, linear algebra and multivariables, like go look, what can you find? What are they doing? If you can see any published final exams or syllabi from these elite institutions, along with the most popular, most well-respected textbooks that are used at those institutions, what are they covering? Like what's the superset of the commonality, right? There's always some, Justin would always point this out, there's always some really weird idiosyncratic topic that some professor covers because maybe it's related to their area of research and they just find it neat, but nobody else will talk about it and everything's kind of weird. But if you shave those off and you're like, okay, they covered this at MIT and this at Caltech and this at Stanford and this at Chicago and this at Duke and this at, and you go all that and you go, okay, what is that? Because you don't want to go, well, they don't cover this and we cover this at MIT. It's like, well, they didn't cover that at Stanford and they didn't cover that at, at Oxford. But you look pretty broad, far and wide to just make sure that we're covering all this stuff, right? I mean, just talk a little bit about that, because I find that interesting.
Yeah. So, in terms of what a differential equations course should look like, there does seem to be like a sort of a general consensus among the top universities, like US universities. So so we sampled, I think, like 8 to 10 of the top universities in the US and came up with a list of topics which they all seem to cover, plus some, plus a handful which some of them cover, some of them don't. And it was from there that we kind of really came up with our first kind of course outline. Now, we are somewhat constrained in the sense that, it needs to be a semester long course. So, maximum 200 topics for a course like this. So that is kind of a constraint. But I think that the differential equations course we have planned is going to cover everything that you see at most of these universities. You always get people online sort of asking, hey, you're going to have PDEs, you're going to have signal processing and this and that. It's like, well, they're typically covered in like later courses. We're just doing a extremely comprehensive differential equations course, but it is an introduction to differential equations. It's not going to be, sort of pulling in things from like you wouldn't normally expect to see.
Yeah, it's the same kind of scope creep that we saw in machine learning, or even in the linear algebra, right? Like people often confuse like Axler's linear algebra done right. No, that's a second linear algebra course. You wouldn't see that in a first semester linear algebra course. So it's kind of the same situation with differential equations. It sounds like, right? We have to draw the line somewhere, right? We can't just have it expand out indefinitely until you're doing like research on Navier-Stokes as your final topic. Like, no, we need to keep the scope down.
Yeah.
I mean, I think it's important, as we've talked about this for years, is to have apples to apples comparisons with what we're doing and what is done at a comparable level. So it's like our Algebra 1 course can be, it's a year-long, it's a 9-month course, right? Because that's what's done in schools. When we think of algebra, what is Algebra 1? Now, we could be more comprehensive because you only look at different textbooks and they go a little deeper on this or a little deeper on that. And because we have an extremely efficient pedagogy and learning algorithms, that we can do more, but nevertheless, it still has to be a year-long course. Now, for university courses, they are a semester or quarter-long course. Now, for people who aren't familiar, in the U.S., course, probably 3/4, probably maybe more, maybe 80% of universities run a semester system. So the year is divided into 2. So it would be a half-year course, and you would take, 4 to 5 courses. In some schools where I went to University of Chicago, it was quarter based. So you had a fall, winter, and spring quarters, and so you would only take 3 or 4 courses. So you would do more in less time. Fewer courses that would cover a little more ground. But regardless, they're pretty much the same. It's pretty much the same amount of material. So our university courses need to fit in that framework so they can compare it and go, okay, as a semester, quarter-long course, math course, how does this stack up to what's going on? If you do it like a year-long course, people are like, well, is this like and everybody gets confused. And so we always say, like, we can reinvent a lot, but we do not exist in a vacuum. We exist in a world where things are done a certain way and people have certain understandings and expectations. And if you drift too far off that, then people just do not know how to think about what your product is or what you're doing. And it just becomes so much friction in crossing that it's just it caused the product to fail. So we need to be, okay, people go, oh, so it's Calc 1. Calc 1 is a semester quarter-long course. Calc 2, I get it, linear algebra, so we have to kind of do that. So I think you're right, like put a cap on it. It's ordinary differential equations. It's going to be a superset of most of stuff. So if you go to one of these courses, you won't be able to go, well, we don't cover that. It's like, hell no, we do cover that, cover all that. But we're not going to go crazy. And then we can do the partial differential equations course or something like that as a second course later. I mean, I think we have, our sort of goal is to get the lower courses first. So I think differential equations is sort of like a legitimate sophomore or junior level course, depending if you're applied math, you might take that your sophomore year. I mean, you would take, the standard is you take Calc 1 and Calc 2 as your freshman year. You would take linear algebra, multivariable calculus your sophomore year, maybe differential equations, or maybe your differential equation would be a junior year. I was pure math, so I never even took differential equation. Mine was real analysis, abstract algebra, and stuff. So, but if we get this down, if we get differential equations down, I feel like we've covered most of the lower introductory level, sophomore, junior level stuff. Now, pure math, of course, we would have to do real analysis. I'd cover that. So, I mean, Alex, go on, Alex. I mean, Justin, go on. Say.
Oh, I was just gonna say, yeah, this is like the last course in the core engineering sequence,
right,
for an undergrad. I think that's like the special part about it. But yeah,
a lot more people would need to know differential equations and need to know real analysis.
Yes.
So it's a better or abstract algebra. But then after this, so the goal for differential equations is we'll have it done by the new year. And then after that, it's on to, I mean, obviously we're going to try and roll out machine learning, but that's not really a content thing. That's more a technology thing. At this point, the content is basically done. It's abstract algebra.
Mm-hmm.
Alex, is that what you're thinking?
Yeah, I think we can get the ball rolling on abstract algebra, but we've. I mean, maybe this is a conversation for another day. But sort of upgrading the kind of like the proof infrastructure, and probably rolling that out into something like methods of proof first, and then but working on abstract algebra, because not all abstract algebra is going to be like require like free form proofs. There's still a lot of stuff we need to do on the content end. So, but yeah, broadly speaking, get some proof infrastructure in place. Then methods of proof, update that to have the free form proofs, then onto abstract algebra, and then real analysis.
Yeah. Okay. So we won't go into detail on that. But so differential equations course, how are you feeling about it? I mean, is it as a course?
Yeah, I feel good. I mean, it's yeah. I mean, I think that we are kind of like. I'm excited about it for sure. Yeah. It's because we've got all this existing content already, and we're kind of like filling in the gaps. It's kind of like it's a little bit difficult to see the wood for the trees in some sense at the moment. But I think it's going to be a great course. And one thing is as well I was going to say is that there are opportunities to enhance this course, like some of the like the numerical methods. We've learned a lot about how to deal with like highly numerical work, sort of like basically doing algorithms but by hand,
range kata and things like that,
stuff like that. Yeah, so we in the calculus courses we've got something called Euler's methods, which took a few iterations to get right, but now that we've got it right and the pass rates for that are really high, it's like you just need to carry that same methodology through to the differential equations course. So we know we know it should work. I mean, it's the same thing but just sort of it's slightly more complicated, but then once we have the coding infrastructure in place, we can have like coding courses so students can kind of complete the loop. It's like they do it by hand, they get proficient, and then we give them like a cool coding project where they actually have to, predict something about the weather using like the Runge cutter method or something like that, which I think would be really cool and help to kind of square that off.
Yeah, that'd be awesome, because differential equations opens up so much surface area to cool modeling projects. I mean, I remember back when I was really getting interested in applied math, that was the thing that did it for me. Differential equations, modeling everything, biology, weather, whatever. So yeah, I'm sure we could get a ton of cool projects out of that.
Yeah, so there's going to be a lot of potential. Once the course is done, there's a lot of potential there in like a V2 where we do some more projects that involve coding and modeling and things. So yeah, that's going to be really exciting.
Yeah, I guess it's like the coding thing is interesting because we could have versions of courses that require coding or don't. It'd be interesting
Yeah.
to have like you could do differential equations, you could do linear algebra, you could do all these things multi-row. You could have a code which just has a ton of coding projects with or without coding. It's like linear algebra with coding or something.
Yeah, it's like a topping, like a pizza topping. You want
Yeah, you want
coding?
pepperoni, you want whatever, you want sausage or not,
Yeah.
And some people are like, I don't know how to code, I don't know. But some people are like, yeah, because that really will bring it to life for a lot of students. Is like writing the code, it's kind of I talk about building the tools. You once you write the code to do stuff, it's like you just kind of mentally, at least for me, I sort of mentally own it, cognitively own it. I'm like, yep, I got it now. I totally get it. I can see the solution in my head now. But one thing I was going to say, the Euler's method was the Euler's method topic. I kind of remember that was a real problem early days, right? We had a really low pass rate on that, and that took some effort, didn't it, to get
It
that
took
right?
some effort. Yeah, it stands out as being one of the topics I found that was quite hard to teach in like an online in our setting. Is like we just didn't. I can't remember. It's quite a long time ago now, so I can't quite remember the efforts. But I remember we tried sort of teaching it. As you might find in regular textbooks, that didn't work exactly. So we iterated on it. Still didn't work. I think it took sort of 3 or 4 goes, and in the end, we came up with like this really sort of sleek, simple notation, a kind of like a tabular approach, which kind of avoids a lot of indexes. I think I call it index hell when there's just unnecessarily indexed, Y, I, J, all that kind of stuff. You want to avoid all that as much as you possibly can because it's just cognitive load. Wait, what does that index mean? Was that index? This approach, the approach we settled on, avoids all of that stuff. So we're just going to carry that through to these other methods. There's other things you can do too, like to sort of help build intuition. So, before we even start with Euler's method, we get them to kind of like do like a tangent line approximation, by hand, so they kind of visualize, okay, this is what we're actually
This is what
doing
we're
here.
doing. This is what we're actually.
Yeah.
This is
And then you formalize it in the form of Euler's method. And then once you've got that down, it's like, okay, well, now we can improve Euler's method because Euler's method kind of sucks. So,
Mike, when I taught it the BC calculus course, my kids, they hate that. They hated Euler's method. They're like, because you make the big table and it's boring. It's annoying.
Yeah.
I mean, it's a computational process. Yeah. It's supposed to be done with a computer, not really a human hand.
Yeah, true.
I mean, unless you're there in the 1800s and you're like, well, this is the best I can do.
Yeah. But you really need to do those as painful as they are, you really need to do them so they get under your skin. So when you actually come to code something like that, you know exactly what's going on. It's very easy to sort of look at a formula, create like a Python script, which is like 30 lines long. It kind of gives you an answer. It's like, well, don't really know what's going on here. It's exactly the same mentality we've got with this machine learning course. It's like, we want people to do gradient descent by hand, so it really gets under their skin. So when they actually translate that into like a coding environment, they know exactly what's going on. It's
going to get under their skin in more ways than one. And one of them, they're like, I ain't doing that. But then they will know it. It's like, dude, like now you know it. I know you didn't love it, but now you've mastered it. You intuition through repetition.
Yeah, I mean, it's one of those things. I mean, like, when it comes to things like gradient descent, I mean, we were talking earlier on in the show about, people that sort of like, they kind of like started the top down method of becoming machine learning engineers and never really did the bottom up part. So they kind of vaguely know what gradient descent is, but not really. And it's like, that's not a good position to be in if you really want to make kind of like cutting edge technology or pushing the boundaries on things. It is a necessary evil to kind of to go through those painful calculations by hand.
Got to get inside the trade, as you say, Jason.
That's right. It's such you earn your beans. That's where it's like you learn, you develop that intuition, and then you can the abstractions stuff all fall into place. But if you try and skip the concrete examples, skip the repetitions, and go straight to the abstraction formulas, you're just like cargo cult math. You're just parroting stuff. You sound
the buzzwordy.
You sound like you know what you're talking about. Yeah. Oh yeah, blah. It's like, okay, they're like, they can't really solve anything.
The nice thing about some of these numerical methods is that even the more complicated ones like RK4, it's like they are actually extremely intuitive if you actually spend the time to get the notation right, to get the examples right. So yeah, they've got there's every opportunity for it to get under their skin to the point where they know it really well, without necessarily completely hauling over the coals.
Yeah. Well, I'm excited. Well, I think it's going to be, I'm sure it'll be top notch, and I'm excited to see it as it come together. So,
Yeah.
well, I guess we should probably wrap it up. This has been another long one. I mean, Justin and I was talking about, we keep it an hour and a half, and hour and a half. And Justin's like, have you ever listened to yourself, Jason? That's not even remotely realistic. I don't know what you're smoking. So, all right. So we're 3 hours. Okay, Alex, sorry. I know this is much longer than you were probably expecting, or
actually, I wasn't. I was kind of expecting it to.
I know you,
You
Jason.
just planned for it at this point.
This isn't my first call with Jason. You're like, Cremmy, I'll maybe see you tomorrow. I don't know. We'll all right, cool.
It's good though. We covered a lot of bases.
Yep. All right, guys. So let's wrap it up, and that's a show.